Hey guys, in this video we are going to go through the Babel website and try to pick up some of the good things we can learn from Babel and probably use that in our projects as well. So I have created a gist from using GitHub where I listed down some of the cool things which I found here. So yeah, let's go through them one by one. First thing which I found was run s. So this is going to run npm scripts sequentially. And related to this, I also have a run p, I think. Yeah, so run p is going to run the commands parallelly. So in package.json, we have run as bootstrap sponsors and build. So this run as is going to run these two scripts sequentially. So bootstrap sponsor is going to run first and then build. So yeah, and for our run p here, so in start it's going to run start repl and start Dr. Soros. So yeah, I think this is pretty cool to take a simple command to run the script sequentially. Otherwise you need to use the ampersand command to run them sequentially. Let me enable my screen fast forward. Right. So the next point was to, getting a file size of a code snippet. So as you can see here, this is the try it out or the REPL version of Babel, REPL page of Babel. So here we put in the code on the left side and we get the compiled code on the right side. And if we enable file size here, we can get the file size as well. So how are they calculating the file size? Well, it's very interesting how they're calculating file size. The idea is they have the code here. They're having the code, like whatever code we are putting in here, they're getting the code here, and then they're creating a new blob with the code and type as text slash JavaScript. And then once you create the blob, you can get the blob size. So I think it's pretty nice way to get the file size of some code or even like any text maybe. So you have like simple words and anything, so you can just get it like that. So yeah, this is pretty neat. So next thing is evaluating users code in an iframe. Yeah, so whatever code user is passing here, let's say that code may itself be window location href is equal to google.com, so or window dot close or anything like not sure if it's going to close or something, but yeah, user can do anything whatever they're passing here, right? So like Babel needs to execute this code in a sandboxed mode so that they can be sure that this code is actually valid code. Like if this code itself is not valid, then there is no point in compiling this to transferring this code to ES5 code or whatever target is. So to check if the code is valid, Babel needs to execute the code, and they can execute the code in try catch. But if the code contains valid JavaScript syntax to close the page or to rewrite to another page, then that's going to cause issues, right? Like while evaluating the code is correct, Babel itself, like this site itself went to another page, like this is going to another page, so that's bad, right? So to solve that, what Babel is doing is they're creating iframe inside this page somewhere with the width and height as 0 so that it's not visible to us, and then it is executing this code inside the iframe context. And yeah, so basically if they're doing that, then whatever happens in the iframe itself, and it won't affect the parent page, and that's why it's like completely sandbox. I mean, it's sandbox to a good extent. Like there are limited things which the iframe can access from the original parent frame. So let's see, using iframe with height 0 and using iframe.content window.eval. So using eval to execute the code, and I repeat again, eval is not bad. So I'm not sure why people say eval is bad, but I don't think it's bad. And even Babel is using eval, so yeah, there are use cases for eval. So eval is not bad if you know what you're doing. Wrapping is in try catch to detect if the code is functionally correct. Yeah, I think this is pretty cool using iframe as a sandbox. Next was while evaluating our code and compiling it, there's a delay, a deviance of 500 ms. Yeah. So whenever we are writing some code here, like if you write too fast and if babel transpiles this code as fast as we are writing, then that's a performance bottleneck. So babel actually waits for 500 milliseconds before it checks if the code is valid and actually transpiling the code. So yeah, so that's a nice use of debuggings here. Next is small implementation of worker message passing. So uh, if you observe this transpiration, like when babel is transpiring from one uh, ES6 to ES5 or ES2020 to ES5, then this transpilation is resource intensive. So if you have used Babel code at some point, you would know that when Babel creates an ASD and it compiles it down to another format, it actually takes up quite some time. So till Babel 6, I think it was synchronous. Babel or transform was synchronous. From Babel 7 is asynchronous, but still, like whatever we are using, it can actually cause resource hogging. So the best way to do that is through a worker, and I think this is a really good implementation of worker, and this is a really nice use case for workers. Because like this if this is imagine this is a big code here, and you need to be able to do that, and if you do this on a main thread, it's going to cause a performance bottleneck. So yeah, so they are doing this on the worker thread, and I think it's a really good implementation of workers. So yeah, really it's really I felt really nice when I saw this. Yeah, so okay, they are doing this in the worker, but then we need to keep in mind about something, and that is workers, like I can pass any message to a worker and it's going to give me back, and like I would know that worker is returning me the response of which message, right? So if there's a worker W, and I'm sending the worker a message, and after 2 minutes I send another message, and like we wouldn't know like workers returning us the which message it's going to return to us. So that's our issue. So to solve this issue, what's usually done is, while we're sending a message to a worker, we also send a ID to the worker. So when it returns us the message, it returns us the ID with the message. So in this way we understand that this worker is reading the message, or is responding to which message. So yeah, so it's pretty cool. So, let's see how they're implementing this. So they are creating a wrapper around the worker. So register from this worker API, and it's worker here, and it is a closure implementation, and they're using a UID map and a counter. So counter is the ID. So now what they're doing is worker.add event listener message. So when the worker is going to send a message, it's going to check from the event.data what is the UID, and then it's going to get, okay, UID map is going to hold a promise with the resolve and reject, and then it's going to get the resolve and reject, and then it's going to remove that, and if there is no error, it's going to resolve with the message. And yeah, and when returning this function, it's going to give us a function of post message. So all this having the UID and all that, this is implemented inside this wrapper. So the caller of the function did not worry about implementing UID and anything, but it's just going to work, and this is going to be a promise. So yeah, this is pretty good actually. Now, let's look at how the worker script is loaded. So we established that running Babel on the Babel transform on the main thread is not efficient. So there is no worker. So now let's see how the worker is loaded. So to load the worker, they're using the plugin worker loader. So this is a webpack plugin which will import the worker and also resolve any dependency issue if there are any. So as you can see, this is how they're loading the worker, but also like I discussed in a previous video, where we can use this plugin to we can use this loader inside webpack.config.js, and we can define a file format, and then this would happen automatically. But nevertheless, it's they're using the inline format, so yeah, it works. So yeah, they're using this loader to import the worker files. Next, run parallel to discuss this. And yeah, this was interesting. So if you observe here, the main page, it has a small this kind of a transformer here. So this is not a video, this is actually a real code editor where we can put in any code and that would get transformed. So what they're doing here is really interesting. So yeah, so let's go to the file and en slash index, I think. Yep. So here there is a REPL, has to be, yeah, mini REPL. So what they're doing here is this mini REPL. This is this component, and here while it is rendering this is importing the script tags. So I think I thought this was really cool how they are importing the script tags when this is being rendered. So it's not going to block the initial rendering, but like when they're parsing the HTML and creating the DOM, then the script tag will get injected. So kind of this is going to happen dynamically. Like at the end of like the entire page load, this is going to happen. Like not exactly that, because yeah, this is going to be evaluated when rendering the HTML, when passing the HTML file itself, but it's not going to happen instantly. So this is a pretty neat way of delaying the execution of the script tags, or delaying the loading of the script tags. And yeah, so and one more observation is like we can load script tags anywhere inside the DOM. We don't need to put it in the head. So yeah, so in the body itself they are putting script tags, so yeah, we can do the same. Yep, so that brings me to the end of my list. So if you have anything which you think is really interesting what they are doing, so you can share in the video comment, or if you have any suggestions you can post in the comments. And in the next video, or in one of the future videos, I plan to reverse engineer the babel code. So let's see what we can find, or what interesting things we can find in babel code, the main file itself, main project itself. And like I believe that it's going to be a really big project. So yeah, so let's see how that goes. So yeah, I hope you learned something from this video, and stay tuned for more such videos. Bye guys.